I'm Sadie. And I'm Vivian.
Hi, I'm Isaac.
A student drops their GPA from 4.0 meters to the ground. After how many seconds does it hit the ground? First, we list what information we already have. We have delta y equals 4 meters. We have velocity initial equals 0 meters per second. And we have acceleration, which equals gravity. So it's negative 9.8 meters per second squared. Remember, we are looking for how many seconds it took for the ball to reach the ground. Then we must choose which equation we should use. What the equation we should use is delta y equals velocity initial times time plus 1/2 acceleration times t squared. Remember, acceleration is gravity. Because the student is dropping the ball, velocity initial is 0. So we plug in our numbers, and our delta y is actually -4 because it's going down. So just keep it in mind. -4 equals 1/2 times -9.8 times t squared. And then when we solve for t equals 0.9035 seconds.
Hello, this is Sadie here to talk to you about kinematics. So, kinematic equations are used to define velocity, final, initial, time, acceleration, and the displacement of an object. Before you try and figure out a kinematic equation, you need to first write your givens and unknowns. Then, you have to find the right equation that includes all of the variables. The equations including velocity final equals velocity initial plus acceleration times time. The second one would be delta d equals velocity initial times time plus 1/2 acceleration times time squared. The last one is velocity final squared equals velocity initial squared plus 2 acceleration times delta.
Hi, I'm Isaac, and I'm here to tell you about Newton's first law. And the definition is, an object in motion remains in motion in a straight line and at a constant speed, or an object at rest remains at rest unless acted upon by an external or unbalanced force, and is also called the law of inertia. Inertia is a quantity of matter, also known as mass. If I was in outer space right now and threw this ball in the air, it would continue forever in a straight line. Watch. Newton's third law of motion states, for every action force, there is an equal in magnitude and opposite reaction time. For example, if this ball hits Vivian, there is going to be an equal reaction from both people.
Hi, I'm Viv the Vector, and I'm going to be talking to you about vectors. So vectors in physics are a quantity that has both magnitude and direction. It is typically represented by an arrow whose direction is the same as that of the quantity and whose length is proportional to the quantity's magnitude. Some examples of vectors are acceleration, velocity, direction, and forces. So you always want to draw your vectors first, and you always want to draw them tip to tail. And if two vectors point in the same direction, you want to add them together. But if two vectors point in opposite directions, decide which one is positive, the other one is negative, then you add.
So for perpendicular vectors, you always want to draw the vector tip to tail. And what shape you want to see is always a right triangle. The sides of the vectors are called components, and the hypotenuse is called the resultant. To solve for this resultant, we use Pythagorean theorem, and to solve for directions, use trigonometry functions such as sine, cosine, and tangent. So let's do an example of this. So a man is going Christmas tree shopping and wants to find the perfect tree. To find the perfect tree, he walks 95 kilometers east and 55 kilometers north. Calculate his resultant and displacement. So we draw the right triangle, and 95 kilometers and 55 kilometers are his components. And we want to find his resultant. So we use Pythagorean theorem, r equals 95 squared plus 55 squared, all under square root, which equals 110 kilometers. So that is his resultant. But we want to use, to solve for direction, we use the trig functions. So we do 55 over 95, one of the components over the other, equals 30 degrees. So the answer comes out to be 110 kilometers at 30 degrees. The man's resultant displacement. What if we have two vectors that are at angles? The first thing we want to do is draw the vectors tip to tail. The second thing we want to do is to resolve our original vectors into x and y components. Then we want to add components in the same direction. Next, we want to draw new right triangles using your components. And then we want to use Pythagorean theorem and then trigonometry functions to get our answer. So let's do an example of this. So what if the man who went Christmas tree shopping walked 65 meters at 25 degrees, and then he turned and walked 25 meters at 125 degrees? What is his displacement? So our first step is to draw vectors tip to tail. Then we are going to look at our components and do the trig function. So we do x equals 65 cosine 25, which is 58.9 meters, and then we do y 65 cosine sine 25, which is 27.5 meters. And then we want to make our charts, so we would plug those numbers into that. And then the other part, which would be walked at 25 meters at 125 degrees, we would do 25 cosine 125, which would give us that, and then which would give us our x component, and then we would do 25 sine 125, which gives us our y component. We always want to make a chart because it would be a lot easier. So when you add this together, you get 44.6 and 48.0. To get our resultant, you square the total. You square the x total and the y total and all over square root, which gives you 65 meters. And then we do the same thing to find our degrees. We do inverse tan, which is 48 over 44.6, which is 47 degrees. So the answer comes out to be 66 meters at 47 degrees relative to 0. And this is how we find if we have two vectors that are at angles. So the basic and recurring theme in physics is to take all vectors and turn them into one big right triangle.